Preparing for AWS Cloud Engineering interview? You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a secure VPC for a production web application on AWS? A VPC is the isolated network boundary where I define IP ranges, subnets, routing, and security. I place internet-facing resources, like load balancers, in public subnets with a route to an internet gateway. Databases and application nodes usually sit in private subnets, reaching updates through NAT. I separate availability zones for resilience, keep CIDR space planned for growth, and use route tables, security groups, and ACLs to control traffic. While answering, focus on CIDR planning, public versus private subnets, route tables, internet gateways, NAT gateways, security boundaries, multi-AZ layout, and how VPC design supports availability and future growth. Question 2. What is the difference between security groups and network ACLs in AWS? Security groups are stateful firewalls attached to ENIs or resources, so return traffic is automatically allowed. NACLs are stateless controls at the subnet boundary, requiring explicit inbound and outbound rules. I use security groups for application-level access, like ALB to EC2 on port 443, and NACLs for core subnet guardrails. In troubleshooting, I check both, plus route tables, because a deny at the NACL can silently block otherwise valid traffic. Make sure to cover stateful versus stateless behavior, resource-level versus subnet-level filtering, allow and deny rules, rule evaluation, common troubleshooting scenarios, and when you would use each control. Question 3. How do you implement least privilege access using IAM and AWS? I start with least privilege. Grant only the actions, resources, and conditions the workload needs. IAM roles are preferred over long-lived access keys because temporary credentials rotate automatically through STS. For humans, I use Identity Federation and MFA. For cross-account access, I create a trusted role in the target account and restrict who can assume it. I also validate policies with Access Analyzer and review CloudTrail for unexpected usage. In your answer, talk about IAM users, groups, roles, policies, temporary credentials, permissions boundaries, MFA, cross-account access, policy conditions, and how you audit or validate overly broad permissions. Question 4. How does an auto-scaling group work, and what would you configure for a production workload? An auto-scaling group keeps the desired number of EC2 instances running and adjusts capacity based on demand. I usually launch instances from a versioned launch template, spread them across multiple AZs, and attach them to an ALB target group. Scaling policies can track CPU, request count, or custom CloudWatch metrics. The key is graceful lifecycle handling, health checks, warm-up time, connection draining, and immutable deployments so new instances are predictable. Be sure to mention launch templates, desired min-max capacity, health checks, scaling policies, CloudWatch metrics, multi-AZ placement, lifecycle hooks, load balancer integration, and graceful instance replacement. Question 5. When would you use an application load balancer, network load balancer, or gateway load balancer? ALB is best for Layer 7 HTTP and HTTPS routing, host paths, headers, redirects, and WebSocket support. NLB is Layer 4, built for very high throughput, static IPs, and low latency TCP or UDP workloads. Gateway load balancer handles transparent network appliances, like firewalls. In most web architectures, I put CloudFront in front, ALB for application routing, and health checks tied to auto-scaling target groups. While answering, compare Layer 7 and Layer 4 routing, protocols, latency, throughput, static IP needs, TLS handling, target groups, health checks, and appliance-based traffic inspection use cases. Question 6. How would you secure and optimize an S3 bucket used by an application? S3 gives durable object storage, but good design is about controls around it. I enable bucket policies that block public access, unless explicitly required, use SSE S3 or SSE KMS encryption, and turn on versioning for recovery. Lifecycle rules move old data to cheaper classes like infrequent access, glacier instant retrieval, or deep archive. For access patterns, I consider multi-part uploads, pre-signed URLs, replication, and event notifications. Make sure to cover bucket policies, block public access, IAM access, encryption, versioning, lifecycle rules, storage classes, replication, access logs, pre-signed URLs, and event-driven integrations. Question 7. Explain the difference between RDS Multi-AZ and read replicas. Multi-AZ is primarily a high-availability feature. RDS keeps a synchronous standby in another availability zone and fails over when the primary has issues. Read replicas are for scaling read traffic or supporting reporting, and replication is usually asynchronous. I don't use a read replica as my only HA plan because data can lag. For production databases, I combine automated backups, multi-AZ, parameter tuning, and tested failover procedures. In your answer, distinguish high availability from read scaling, synchronous versus asynchronous replication, failover behavior, backup strategy, replica lag, regional replicas, and typical production database architecture choices. Question 8. How do you decide between Lambda, ECS, EKS, and EC2 for running an application? Lambda is ideal for event-driven work where I want no server management, quick scaling, and short-lived execution. I choose ECS or EKS when I need containers, custom runtimes, long-running services, or more control over networking and deployment. EC2 fits specialized agents, legacy software, or deep OS tuning. The trade-off is operational control versus operational burden. Serverless reduces patching, but containers and EC2 offer more predictable runtime behavior. Be sure to mention execution model, operational overhead, scaling behavior, cold starts, runtime control, container orchestration, networking needs, workload duration, team skills, and cost trade-offs. Question 9. What roles do CloudWatch, CloudTrail, and AWS Config play in monitoring and governance? CloudWatch tells me what is happening operationally: metrics, logs, alarms, dashboards, and events. CloudTrail tells me who did what in the AWS API, which is essential for audit and incident investigation. AWS Config tracks resource configuration history and compliance rules. In a mature environment, I use all three together: detect symptoms with CloudWatch, investigate actions with CloudTrail, and verify drift with Config during regular reviews. While answering, focus on operational metrics, logs, alarms, API activity auditing, configuration history, compliance rules, incident investigation, dashboards, alerting strategy, and how these services complement each other. Question 10. An EC2 instance in a private subnet cannot reach the internet. How would you troubleshoot it? I troubleshoot from the packet path outward. First, confirm the instance has the right private route table and that 0.0.0.0/0 points to a NAT gateway in a public subnet. That NAT subnet needs a route to an internet gateway. Then I check security groups, NACLs, DNS resolution, and OS firewall rules. If only package updates fail, I also verify endpoints, proxy settings, and outbound allow rules. Make sure to walk through route tables, NAT gateway placement, internet gateway routes, security groups, NACLs, DNS settings, subnet associations, OS firewall rules, and VPC endpoints. Question 11. How would you build a highly available architecture on AWS? High availability starts with removing single points of failure. I deploy across at least 2 availability zones, use load balancers, auto-scaling, manage databases with multi-AZ, and stateless application nodes. For regional resilience, I consider Route 53 failover, data replication, and separate infrastructure stacks. The right level depends on business impact. Multi-AZ is common baseline, while active-active multi-region adds cost, latency, and operational complexity during incidents. In your answer, talk about multiple availability zones, load balancing, auto-scaling, stateless services, managed databases, health checks, failover, regional resilience, data replication, and eliminating single points of failure. Question 12. How does Route 53 help with DNS routing and failover? Route 53 is AWS's managed DNS service, and I use it for more than simple name resolution. Weighted routing supports gradual traffic shifts. Latency routing sends users to the closest healthy region, and failover routing works with health checks for DR. Alias records are important because they map cleanly to AWS resources like ALBs and CloudFront without extra DNS cost. TTL choices affect failover speed and caching behavior. Be sure to cover hosted zones, record types, alias records, health checks, routing policies, TTL, latency-based routing, weighted routing, failover routing, and multi-region traffic management. Question 13. How do you manage encryption keys and application secrets in AWS? Secrets should not live in AMIs, Git, environment files, or user data. I store database passwords and API keys in Secrets Manager when rotation matters, or parameter store for simpler configuration. KMS protects the encryption keys and gives auditability through CloudTrail. Applications receive access through IAM roles, not embedded credentials. I also scope decryption permissions tightly, because broad KMS decrypt access can bypass otherwise good secret controls. While answering, discuss KMS, Secrets Manager, Parameter Store, Envelope Encryption, Key Policies, IAM permissions, rotation, audit logs, application access patterns, and avoiding secrets in code or AMIs. Question 14. Why is infrastructure as code important, and how would you use Terraform or CloudFormation on AWS? Infrastructure as code makes environments repeatable, reviewable, and recoverable. I define networks, IAM, compute, and manage services in CloudFormation or Terraform, then apply changes through CI/CD with approvals. State management matters, especially in Terraform, so I lock remote state and separate workspaces or accounts. I avoid manual console changes because they create drift. The best practice is small modules, tagging standards, and automated validation checks. Make sure to mention repeatability, version control, peer review, drift detection, modular design, remote state, CI/CD integration, environment promotion, rollback, and preventing manual console changes. Question 15. What is the difference between a NAT gateway and a NAT instance? A NAT gateway is managed, highly available within an AZ, and scales without me maintaining instances. A NAT instance is cheaper in some small environments but needs patching, scaling, source destination check changes, and failover design. I place NAT gateways in public subnets and route private subnets through the NAT in the same AZ to reduce cross-AZ charges. For AWS Service Access, VPC endpoints can cut NAT costs significantly. In your answer, compare managed availability, scaling, maintenance, cost, routing, public subnet placement, security group support, source destination checks, failover design, and VPC endpoint alternatives. Question 16. When would you use SQS, SNS, or EventBridge in an AWS architecture? SQS decouples producers and consumers with a durable queue, which is perfect for background jobs and buffering spikes. SNS is pub/sub. One message can fan out to email, Lambda, SQS, or HTTP subscribers. EventBridge is for event routing across AWS services, SaaS tools, and custom buses with filtering. I choose SQS when ordering, retries, and back pressure matter. SNS or EventBridge when multiple systems need notifications. Be sure to cover queuing, pub/sub, event buses, fan-out, filtering, retries, dead letter queues, ordering, decoupling services, back pressure handling, and common serverless integration patterns. Question 17. How would you implement blue-green or canary deployments on AWS? For blue-green, I run 2 production-ready environments and switch traffic from old to new, often using an ALB, Route 53, or code deploy. Canary releases shift a small percentage first, then increase if metrics stay healthy. I watch error rate, latency, saturation, and business metrics, not just deployment success. Rollback must be automated and fast. The trade-off is safer releases versus extra capacity and pipeline complexity. While answering, mention code deploy, ALB target groups, Route 53 weighted routing, ECS or Lambda deployment strategies, health metrics, automated rollback, observability, and capacity planning during releases. Question 18. How does CloudFront improve application performance, and what configuration choices matter? CloudFront reduces latency by caching content at edge locations close to users. For static assets, I set long TTLs with versioned file names. For dynamic content, I cache carefully based on headers, cookies, and query strings. Origins can be S3, ALB, API gateway, or custom servers. I also use origin access control for private S3, WAF for protection, and invalidations only when necessary because cache design affects both performance and cost. Make sure to cover edge caching, origins, TTLs, cache keys, invalidations, signed URLs, private S3 access, compression, WAF integration, HTTPS, and balancing performance with freshness. Question 19. How would you design disaster recovery for a critical AWS application? Disaster recovery is driven by RTO, how fast we must recover, and RPO, how much data loss is acceptable. Backup and restore is cheapest but slowest. Pilot Light keeps core services ready. Warm Standby runs scaled-down infrastructure, and Active serves traffic from multiple regions. I design the data replication first, then automate infrastructure creation and test failover regularly, because untested DR is mostly a document. In your answer, discuss RTO, RPO, backup and restore, Pilot Light, Warm Standby, Active, cross-region replication, DNS failover, runbooks, automation, and regular DR testing. Question 20. How do you approach cost optimization in an AWS environment without hurting reliability? Cost optimization starts with visibility. I use tags, Cost Explorer, budgets, and anomaly detection to find owners and trends. Then I right-size EC2 and RDS, choose savings plans or reserved instances for steady workloads, delete idle resources, tune storage classes, and reduce data transfer surprises. I don't optimize blindly. I protect reliability targets first, then use metrics to remove waste without creating performance or availability risks. Be sure to mention tagging, Cost Explorer, budgets, right-sizing, savings plans, reserved instances, spot usage, storage lifecycle policies, data transfer costs, idle resources, and reliability-aware optimization. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.